whoever will come later. So thank you very much for being here. I appreciate your coming to the solutions track. I'll try to make it less product pitch that you would expect from this track, and I hope you like it. So we're going to talk about DevOps at scale, and it will be a real Greek tragedy in 3 acts. And as you would expect from Greek tragedy, everybody dies, right? A lot of sadness. That's DevOps. That's what it is. So yeah, we'll see. Of course, we'll start with the proper prologue. We will dive into it slowly. And this is me. My name is Baruch. I am developer advocate with JFrog. And JFrog are the company behind those cool t-shirts, right? We have a booth downstairs on the 3rd level when you can get one of those t-shirts and also get a chance to win an amazing Amazon Echo. And we also do software, by the way. So when you are down at the booth, you will hear about our software as well. I will mention a couple of our products today during the talk, but not very heavily. For more details, 3rd floor, our booth, t-shirts. Did I get your? All right. Okay, yeah, I'm Jer Baruch on the internet, Twitter, and we're not, so it will be a good time to connect there as well. And there is a new version of Docker, look at that. And I will ignore it, as I usually do with new versions of Docker, for the reasons we are going to mention. All right. Show notes. I prepared kind of a landing page for you to visit during this talk, after this talk. It's jfrog.com/show notes. You'll find QCon section there with this talk. And it also already includes the slides. By tomorrow, I will upload the video of this talk over there. So if you want to watch it again or share it with your colleagues, tomorrow it will be there. And all the links to all the things and most of the products that I will mention, JFrog and not only, are all there. There is a small raffle. It's like I'm keep giving you stuff for free. So that's another one. As a thank you for coming to this talk and to this page, there is like a little raffle form there as well. So let's start. Let's get to business. And of course, the first question will be, what the hell is DevOps? DevOps is not a new concept, and it's been around for a couple of years, but still people are wondering, what the hell is it? And there are a couple of ways to look at it, and I'll present two, both of them as Venn diagrams, because everything can be explained in Venn diagrams, including DevOps, right? So that's the first view, and this is kind of the traditional view of DevOps. We take development, we take operations, we kind of merge them together, and hence the name DevOps. Somewhere down the road, people realize that maybe quality can be important as well, so they kind of added QA into it. The name Dev, QA, Ops, QA, Dev, Op, that didn't play right. So the QA guys had no participation in the name, but it is a big part of the product, so of the concept. So DevOps is right there. But in order to blend all those three, another set of 3 things have to change, and those 3. So first of all, technology have to evolve. We have to have tools that work with both Dev and Ops and QA. The people should evolve. The Dev people should start to understand Ops, and the Ops people should stop doing what they did previously, whatever it was. And the process, it's a lot about process. So here is another sweet spot that makes DevOps happen. And today, we're going to talk about blend of those 3. And we're going to talk about fictional company that it's called Pentagon Inc. And there is a lot of pun intended in the name that we will talk about later. The first is they do transaction, like financial transaction management. They process credit cards, and you can think about a company with the name as a geometrical shape that does that. We just added another corner to it and got pentagon out of it. So let's start. So the first act of our strategy, called the reactive ops, also known as fire brigade, also known as bucket brigade, and many other insulting names. And there is a picture there in the background. Let's start with setting the stage. So let's start with people, and we are talking about small startup that 3 guys just founded. All 3 of them are developers. They come from an on-prem background, like developing on-prem products, probably again, hence the name, come from defense industry. They're smart guys, right? They know exactly what they are doing. A little bit of hipsterish, so they have a very hipsterish stack. So they use all the buzzwords, JavaScript and Node.js and reactive and microservices, but they're smart guys, so they build a product which makes a lot of sense. And the usage of those technologies are in the right places and for the right reasons, let's put it that way. In process, again, this is a very, very tiny startup, 3 people. So they don't need a lot of a process just yet. So they do Kanban as the minimal agile methodology that, again, makes sense for this stage. They put a lot of emphasis on QA, because you remember QA is a part of our Venn diagram, and test-driven development with a lot of unit integration, automatic tests, very good coverage, good quality of tests, and it looks like everything is covered there. Well, ops. They don't need ops, right? None of them have any ops background, but what they heard is they attended QCon a couple of years ago, and they heard about this serverless trend that speaks about we don't really need servers, all we need are services, and this no ops trend that we don't actually need ops, just, everything will work as a service in the cloud, no real ops. So, and that sounds very good to them because they don't know server administration, they don't know ops. So it's like, okay, we don't know that we don't need it. Everything's fine. Is it? Great strategy. Bad ending. Okay, that's all right. So tools. Again, very simple stack, right? The required minimum and nothing else. So they use something like Jira or even GitHub issues for managing their backlog and the issues that arise. GitHub, as as every developer in the world more or less, they use GitHub. Travis CI, heard about Travis CI? Who heard about Travis? Wow. I usually get 1 or 2 hands. So Travis, okay, another question, heard about Jenkins? Everybody, good. Okay, just checking. So Jenkins is a CI server that takes your source code and builds whatever there is. Travis CI is exactly the same idea, hence the name CI. It is a CI server that takes whatever in your GitHub and builds whatever is there. The difference is Travis CI is in the cloud, right? And as you might notice, those guys didn't install a single piece of software on their servers, right? They have Jira in the cloud, GitHub in the cloud, CI server in the cloud as well. Travis CI works for that. And then here comes the no ops serverless part. They use a platform as a service, Amazon Beanstalk in this example, but it can be any other platform as a service, to deploy their code into it. And if you remember, we're talking about bunch of NPM of Node microservices, right? Beanstalk knows how to run Node applications, so they just install a bunch of it and everything looks fine. So this is how the reality looks for those guys in this stage of their DevOps journey. And now let's get to action. And Act 1 in our startup life, after we set up the architecture and wrote some code and have some minimal valuable product, is waiting and singing to potential customers about how great their platform is. And eventually they successfully manage to convince, let's say, an internet celebrity that now has her own fashion brand. Maybe her name starts with K and the last name starts with K, but maybe not. So she decides that she will go with them, and all the transactions for all her fashion stuff will go through their platform. And that's a reason to drink, right? So they drink, they celebrate, it's a big win, and it is, right? It's 3-people company that got a huge celebrity name as a customer, and you know, Friday night, everybody drunk as hell, and like 2 a.m., good times, and then customer calls. Nothing works. So the first reaction is the right one. And after a while, they kind of get themselves together and they charge, right? They're gonna fix it. Now, all of them obviously have root access to the prod because they just wrote it. Those are the 3 founders, and they, you know, personally log into the system and start searching for the problem. And obviously they need to look at the logs. Where exactly are the logs in this serverless service? And when they find the logs, it's like a lot of logs because they have those microservices. Every one of them have a log of its own. And okay, here's an exception. And interesting, it says 1 a.m., but it traces back to another server in which, to another service log in which it's 3 a.m., right? Because time zones. So they do some time zone acrobatics around it and try to figure it out. And eventually they figure it out. The story goes that one of those 3 guys, in the middle of their party, like around midnight, after a good amount of booze, he has a great idea, like another killer feature. So he goes and codes it. And he submits it, and after 10 minutes, 20 minutes, whatever the tests are taken, it's in production. Well, and apparently he broke something, but the fix is easier, right? All we need to do is find the previous commit and deploy it instead, build and deploy it instead. And so they try to do that, and it won't build. Now, this is very strange because it just went to production a couple of hours ago. And now it won't build anymore. What happened? Well, who heard about NPM gate, also known as unpublished gate? Okay, that's the right amount of people, almost nobody. But I trust you, but I can assure you, you experienced the outcome of this great story. And the story goes like that. There is a central repository for NPM packages, which is called the NPM registry. And every NPM application in the world depends on this registry to get their dependencies from. The NPM works in a very interesting way. Not only it checks for new dependencies when they are added, it also checks for every existing dependencies that they are still present. I don't know why this check exists, but this is how it works. And a couple of months ago, there was quite a big scandal when one of the developers, he had a very popular package, NPM package, which is called leftpad. By the way, leftpad, it's 12 lines of JavaScript code that pads a string from the left. This is why it's called leftpad. Now, it's wrapped as a dependency, and more or less all the internet, directly or transitively, depends on this package. And I lie you not, all the internet depends on this package. And after a fight that he got with the administration of this central repository of NPM registry, he decided that he's going away and take all this stuff with him. So he unpublished this module from a central repository. All the NPM builds in the world broke because they all depended directly or indirectly on this leftpad, including those guys. This is exactly what happened, right? So whatever was working a couple of hours ago won't build now because this dependency that they used went away. So they find some caches and they take it on the USB drive and eventually they manage somehow to fix this problem. The problem is that this happens all the time. Right? It's sometimes even the same problems, sometimes those are different problems, but they are in this firefighting mode constantly. And now here is my question for you. This stage, is it familiar to some of you? The firefighting, especially small startup, not a lot of time to put into, infrastructural changes that will fix that. So I've been there. Okay, yep. So you guys know what I'm talking about. And when it changed, when we have money. So this is how we get to Act 2 of our tragedy, which is called reactive improvement. Reactive improvement, it's about installing smoke alarms. We are going to talk about what that means. So let's set the stage again. Let's talk about what changed. So first of all, as I mentioned, money. So there is some money around nice, and now they can hire developers. So they bring on board more developers. Now there are 30 people in total. One developer with ops background. He actually came from ops background. They have 100 customers, which is very nice, big and small. And now they have a support team. They have a support team, so they won't wake up at night all the time when something bad has happened. So this is very good. And they improve the process as well. Now they are bigger, they need a better DevOps process. So they adopted a little bit more structured agile framework, which is Scrum in our example. Who knows what exploratory testing is? What is it? QA team looking for bugs. This sounds very familiar. In my world, it's called manual QA. Manual QA is not a very sexy term, so they invented sexy term. Now it's not manual QA anymore, it's exploratory testing. Well, it means that someone needs to take a look at this system before it actually goes to production. That's a very good idea, right? And especially with this term, everyone should have. Ops. So now they realize that ops do exist. And there is no such thing as serverless, because it just means that it's someone else's server, right? And the fact that everything is in the cloud doesn't mean that they don't need to understand how the ops part works. So this is what this new guy explained to them, and they start to implement it, and we'll see it in a minute, of course, in the tools. Developer on call. Now they have 30 people, and they cannot jump all hands on deck every time something happens. It's a big company. Oh, it's a big, comparing to the previous one, it's order of magnitude. So they have one guy who is on pager duty. Sounds familiar, pager duty? Everybody loves pager duty, of course, right? So one guy, and it's rotating, of course, maybe 3 days, a week, whatever makes sense. And this guy is there, so the support team, which is 24/7, can delegate to him if they cannot find the answer, right? Developer on call. Oh, and they decided they're going to move to London because all these logs, time zones were too painful, right? So they just go straight to Greenwich, UTC, problem solved, and then they look at the prices, and that wasn't really a good deal comparing to what they had previously, so they decided they want to move to Greenwich, but at least all their logs now are in UTC. So at least they fixed that problem. Well, tools, process evolves. Now they really understand that they have this ops part in their DevOps, and the tools evolve as well. So first they have some kind of a knowledge base, and that's for the sake of the support team and the developer on call, their system start to get more complicated, so they need a place to log all their knowledge. GitHub Travis CI says, okay, they prevent the stuff like the NPM gate and generally lack of availability of the central servers by installing an in-house artifact repository, and the JFrog Artifactory naturally is a good thing, and I feel just great speaking about it here because it's the solutions track. I usually struggle with this part because I shouldn't do a lot of product plug, but here I am and I can do it. Yes, JFrog Artifactory, good tool. Wow, that feels good. All right, sorry about that. I'll try not to do that again. All right, so some kind of a repository. There are others, right? And if you are talking about their stack for NPM, so there's others for NPM as well, and for other tools naturally. Beanstalk is still fine, right? Beanstalk wasn't the problem. Sumo Logic or any other tools aggregator. Again, there are logs aggregator. There are a lot. Log entries, logly, Splunk, what else? Logs.io, thank you very much, our Israeli friends, and a lot of other tools. The basic idea is we need to get the logs to one place when they will be correlated with each other, so we will see the context, and it's especially important with microservices when you have logs all over the place, and we can start getting some kind of maybe alerts on stuff that we don't like, or queries for stuff that we want to see, etc. Right? And then here we need to prevent this situation where, you know, the customer calls, nothing works. And the easiest way to solve the problem is with this guy, Pingdom. Someone remembers Pingdom? It's a very, very old tool that does one thing, and it does it good. You provide it with a URL, it goes to this URL and tells you whether this URL is up or down. Right? Cannot get any simpler than that, but it works. So for them, for those guys, it prevents this situation where a customer calls, nothing works. So that's a good thing. Now let's see what happens. So first of all, if you remember, they raised money. What do they do after they raised money? They drink, of course they drink. And again, that's a crazy party going on, and of course it's Friday night, 2 p.m., customer calls. Now, what the customer says, they don't say nothing works because they have this monitoring, but they have something doesn't work. So let's say, for example, they have this credit card processing. So Visa works fine and MasterCard works fine, but American Express fails, right? And now they got to support. Now they have this whole support team that do that, right? And after a while of doing that, they start solving it. And how do they solve it? They know exactly how to solve it. They have the knowledge base. They go there, well, nothing there. But they have developer on call. They call developer on call, and this guy is the only sober guy. Him and the support team are the only sober guys at this night. And they're like, and this guy like, I don't know. I didn't touch this part. It was Billy that took care of American Express. So they need to call Billy. And Billy is not in his best shape. But, you know, Billy said, well, American Express, let me see, let's log in. Now he has the logs, so he can like look at the exception. And he's like, wait a second, this sounds very familiar. I think I saw this error, and I'm pretty sure I fixed that. Let me just log into Jira real quick and we'll see what's going on. And this is something very strange in Jira, because it's fixed but not closed. What does it mean? I fixed it, right? My job is done. It sounds like DevOps not implemented properly, right? Because the only state in which Billy can claim that this problem is solved is that if it is in production. So yeah, so turns out that Billy made a smart choice of utilizing resources, and he made the American Express queue significantly smaller than the Visa and MasterCard. Because of course Visa and MasterCard have much more transactions, but what he didn't anticipate is that the customer will have a promotion. Buy something with American Express and get a free something. And then of course MasterCard queue exploded. And here is a new process that emerged, and it's extremely important. And it is called root cause analysis. Right, so of course, we need to understand what's going on. And this is an example from a live system of a root cause analysis report. This is how it looks, and this is what it should include. So of course, all the environments and all the details with timestamps and issues in their Jira or support system, and total time services affected. All this is important. And here is the log of the events. So in our example, it will be like customer called, and then the support team panicked, and then the support team stopped panicked and started to look at at our knowledge base. And then they called the developer on call, and then they called Billy, and then Billy was very rude, but eventually he did, and all the events. And the real question is, how the hell someone can know that, right? There is a crisis going on, and there was no like court clerk that sits in the corner with their tiny like machine and types really hard what's going on, right? That doesn't happen. So how do they know? And the answer is Slack or any other communication channel that you use. Usually in Slack example, we will open a channel, and others that will be probably a room in which all the stakeholders of this incident will talk, right? So the support and everybody, and logs of this channel is basically that. And you can add here if there was some email communication or anything else, but having all those communications in writing help to construct this RCA very much. Symptoms. And the symptoms was, in our example, American Express cards won't be processed. And then what happened? What happened in terms of description of events? In our case, it will be like, the queue was overflowing and new American Express transactions failed with some exception and all this kind of stuff. Root cause. In one sentence, what happened? And after we discovered it, that's very easy to do. And this is the interesting part, next steps. And remember, this whole act is called reactive improvement, smoke alarm installers. This is our new smoke alarm. We make sure that this problem won't ever happen again. Right? In our example, we can add we can enlarge the queue, we can set up new monitoring, we can add new unit tests, new integration tests, we can add a test scenario for our explanatory QA. We do whatever it takes to prevent this problem happening again. Well, sometimes in very rare occasions, the next steps will be, we evaluated the fix, it's too expensive, we weren't going to do it. But this usually won't happen. Usually we know exactly what to do in order it to not happen again. So this is critical. And now Billy said, okay, my fix will be increasing the queue, right, of American Express. So first I will nuke all whatever in there, and it's nothing important, it's just credit card transactions, we can throw them away, and then we will increase the queue. And by how much? Well, I think I'll double it, or maybe I'll triple it to be on a safe side. Billy has no idea, right? He's just guessing, and that's another problem that we're going to talk soon enough. So this root cause analysis that defines this stage in the life of your DevOps journey is extremely important, not only because you increase the quality of your system, and not only because you save yourself the headache of fixing the same problem next time, but it's extremely important from the business perspective. Now, amazingly enough, your users and customers will forgive almost everything if it happens once and you provided true root cause analysis and the next steps of what you are going to do in order to prevent it from happening. Now, you can be skeptical and you say, really, everything, even if they fuck up my production database and then try 5 different types of restore from backup and won't manage? No, in this case, I won't forget them. I won't forgive them. And I'll give you an example that you will. Who remembers GitLab incident 2 weeks ago? Yes, that was a good one. So GitLab was down for, I think, more than 24 hours. And when they eventually came up, they lost 6 hours of production data. What happened? Well, yeah, someone just deleted a production database. So they logged into prod, and then instead of deleting a staging database, they deleted a production database. How horrible it is? Well, it's definitely not nice, but it's, you know, that's okay. It happens. Good news, they have backups. Or do they? So here is their recovery process. Well, they have snapshots every 24 hours, but no one has any idea where they are. You know what? Eventually they found it, but all the files are empty. Okay, but they have more than one mean to recovery. And here's another one. They did dumps of their database, but apparently they did those dumps with the wrong version of the command line client that didn't match the database version. And this dump failed quietly without any feedback. So they don't have any dumps. But you know what? Disk snapshots, that sounds good. Well, they didn't do any disk snapshots of the DB servers. And yeah, so no SQL dumps, no disk snapshots. Well, maybe replication. Replication should work, they should have another system up. Well, replication procedure is super fragile, prone to error, relies on a handful of random shell script, and is badly documented. So they don't really have replication procedure. Oh, backups to S3. Well, they didn't work. The buckets is empty. In other words, out of 5 backup replication techniques deployed, none are working reliably or set up in the first place. Now, if that's not a major clusterfuck, I don't know for what you can word this. You can use this wonderful word, and it is a wonderful word. But this is like the definition of it. When it comes to, you go to Urban Dictionary and you type in clusterfuck, you get this link. And what do you say? How the customers should react on that? Most of the CEOs in the world would never publish that because it doesn't look good, right? And they did. And the fact that they did it without trying to somehow, you know, they could only leave 3 of them, not 5, right? And they published it very honestly. And that, in a very amazing way, kept their users. Because, yes, that was very bad, but look, they did a honest investigation. We have true root cause analysis report, and of course, they go like pages long on the next steps. And it built trust. You say, you know what? They had the courage and trust to publish that. I want to work with them. Now I see that they won't do those errors again. And here is another very nice example. Yeah, that's my reaction on this stuff. And here's another nice story. who has Google Wi-Fi routers in their home? I guess it's not very popular yet in Europe. So Google have their own Wi-Fi routers now. Those are very nice devices. They do very smart mesh topology. It's good stuff. And those guys pushed an update last week. I was in Atlanta for DevNexus, and they pushed an update as over there, as they usually do. And those updates reset all their routers, like factory reset. Now I get a call from my wife, and she's like, hi honey, I'm back from work, and kids are sitting in the dark. And I'm like, what happened? Is it the power outage? And she's like, no, our Wi-Fi is down. And I'm like, but why the kids are in the dark? And she's like, they forgot that they can go and, use the switch. Because all they know is, Alexa, turn the lights on, and it doesn't work anymore. So they sit in the dark, right? And the thing is, I couldn't do anything, right? I cannot log into my router and fix it because they are factory reset. And the most interesting part, Google cannot do anything. They cannot push a recovery update because all the Wi-Fi spots are disconnected from the network. They are factory reset. And my friend, who is a little bit of Apple fan, was with me, and he's, of course, all Airport Express. Airport, this is how we call it, right? Airport Express. The routers from Apple. And he was advocating buying those instead of those for me when I selected, and I'm like, I'll go with Google, they're good. And he was laughing very hard on me on this day, and he's like, okay, are you going to buy more? And you know what? You know what I told him? I want to see the RCA first, and then I will decide. I want to see an investigation of this incident, and I want to make sure that won't happen again. And then I'll decide whether I want to trust this division of Google. I think the question, should I trust Google or not, is way past, but at least this division or of Google or not, I will decide. And yeah, I wait for the RCA. So yes, so that was a very important step in building a good process. And those guys, they achieved that. Wherever they hit a new problem naturally come, they make sure that this problem won't happen again, and that's a big deal. And now we're getting to our third act of our tragedy culmination. This is where everybody dies, and it's called the perfect storm. So let's see what's going on. First, let's see what's new. There is some more money, and now they have 100 people. A development team of 100 people. They have 5 developers with the ops background. They have a whole performance engineer, like the whole guy. Like real. Chief architect, so that's about time to get someone who understands the system. Customer success team. Now, what is customer success team? Customer success team is, you remember what was the problem with this developer on call that didn't manage to solve the problem? He was not the expert on this matter because he dealt with the other parts of the system. And Billy, he wasn't in any good condition to answer the support call. So customer success team are a bunch of developers on call from every subject matter. So now they know to answer any problem, in theory at least, right? And this is what they do during the night, or this is what their support duty is, to help the support team, and they have each one of those. But also during the day, they find those problems and they fix them as well. And this team is kind of hard to assemble because no one wants to be on this pager call, but it's actually, there are some people that do. This job requires constant context switching and investigation. And there are developers that truly love that. They love this Sherlock Holmes mode of work when they got called, guys, we have no idea what's going on, but something doesn't work, help us find it. And this is what they like. And those are, of course, the natural candidates for being on this group, but also, what's going on? But also, there are other people that need to be there, and they are forced, right? And not only so we will have someone there, but more important, so they will see from the customer perspective, from the supporting perspective, what a shitty product they write. Because pain is instructional. Waking up 2 a.m., no one wants. They will be at their best to prevent it from happening again, right? Oh, they have this guy, legal, right? You know, big company, it's about time, they're in finance, there are tons of regulations to comply. CFO, someone who actually cares about the money they spend, and a good amount of customers, right? They are a reasonably sized company now. And of course, the process evolves. 100 developers, it's like 7, 8 Scrum teams. It starts to be hard to manage. There are frameworks that try to solve this pain. I cannot say that all of them are good or any of them is any good, but this is one of them. It's called Scalable Agile Framework, SAFe. Well, I guess it's better than nothing. And managing 7 or 8 Scrum teams is a hard job for any methodology, so it is what it is. System testing, and that's kind of chief architect that, you know, sees the big picture and looks forward, can actually understand what are the requirements from the system as a whole and put those testings in place. And now ops team. Now this is where you should all get up and get the hell out of the room, because what the hell is ops team? Aren't we in DevOps? Didn't we speak that DevOps means there is no dev and ops, we're all in it together? What the hell is ops team? Why do we need it? And ops team probably is not the best name. What those guys do, they do 2 things. They set up the foundation, the tools, the automatic procedures that allow the rest of the development team be truly DevOps, and they advocate for DevOps inside their organization, right? So when next time the developer said, well, I'm done with my feature, I changed it to fixed in Jira, now it's your turn to take it to production, those guys will come to them and explain, no, it's not our turn, it's still yours. You build it, you own it, you take it to production. Now, if you don't know how to do that, this is how you do it. Those are the tools, those are the techniques, those are the skills. We will help you first time, next time you will do it yourself. And this is the job of those guys. This is what the ops team in the DevOps company looks like and what they should do, right? So that's that. Escalation path. Now, okay, so we already had the support team, we already had the subject matter expert, and now we have something new, manager on call. And here's where you ask, why the hell do I want manager in the escalation path of a technical issue? Right? It's for sure not going to bring anything useful to the firefighting that we do. Well, there are 2 reasons. And by the way, this manager very well may be the CEO in some level of our escalation path. An escalation path looks very simple. If the problem is not solved after X period of time, call this person. And then next, if it's still not called after Y period of time, call that person. The last one on the escalation path is the CEO. And he's there for 2 reasons. Reason number 1, sometimes we need the CEO to make some calls to customers, right? If there is a critical issue with the customer, their system is down, they need to talk and probably play some golf on the next weekend, right? But they definitely need to talk. But the other reason is you want to make sure that this problem won't get to this point when they need to call the CEO, right? There is this time frame after they need to make this call. And it is guaranteed that this problem will go away before, because no one wants to do this call. Right? So having managers in the escalation path is very motivational because pain is instructional. Right? Okay. And those guys are very deeply in financial regulations, and financial regulations are a funny thing. For example, and we're going to get back to the ops team here, one of the requirements of those financial regulations, and generally regulations for the big guys, isn't it 520? It shows 520 on the time. Yeah, so not on the door. Okay, all right, we'll do it in 5 minutes, because why not? So yeah, sorry about that. It's a funny thing, those financial regulations, because, for example, they require separation of duties. They require not to do DevOps. They say, guys, if you're a developer, you cannot take it to production. And we're like, what? We're just talking about how the developer should take it to production, right? So there is someone that needs to sign off the release. You know this process? Someone that will look at that and before it goes to production say, you know, this is safe. This is another job for those guys, right? Although they won't do it instead of developers, they will do it with the developers to sign off the release. Okay, so now, it's been 20 minutes taken from me, but that's okay. Non-functional backlog. Non-functional requirements from the chief architect and from the performance engineer, they now start to emerge. This application should stand at this load, etc., etc. So this is something else. Okay, and tools evolve again. We bring on board configuration management, which is now important, and proper application monitoring, like the pingdom didn't work so well. So we need something like New Relic, something like you know, there are tons of others. Who else? AppDynamics. Thank you very much. Our neighbors from the expo hall and bunch of others. Right. So you need a proper APM, right? Okay. Now let's go to an action. Well, you remember they raised money, so naturally they drink, and then there is a call. Now this time it's not from customer, because on customer front everything is okay. They have NPM, APM, they did all those root cause analysis. This time is the legal calling the health of R&D. And he's like, I'm back from the conference for legal people. And it was, you know, a blast. The most intense conference I ever been. Every talk, I couldn't take my eyes out of the speaker. It was a great content. And one of the takeaways that I bring from this conference is that we're not allowed to use the LGPL version 2.3. Because it was a great talk, I can explain you, and he's like, no, that's fine. Thank you very much. That's, of course, the first reaction to the question, do we use LGPL version 2.3? And then what they do? Well, gets the team and they start looking. Well, at least they have it in one place. All their artifacts are in artifact repository. But still, they need to crack open every NPM package, every Java jar, every NuGet package, and look for the license in it to verify that it's not LGPL version 2.3. And what they do if they found it, they might end up rewriting pretty big pieces of their already written software if they use some dependency which is not allowed. And now, who is this guy? Yeah. The CFO calls the head of development, and he's like, can you give me the projected budget for the cloud operations next year? And the head of R&D goes like, and then he's like, you know what? Sure, I can. This year we spent that much. I will multiply it by 1.42, and that will be a number. And the CFO like, are you sure? And he's like, sure, absolutely, that will be the exact number. Well, but actually he has no idea, right? And then something else. Do you know this guy? Will It Blend? Right? It's a great YouTube channel for whoever doesn't know. This guy blends stuff in Blender, like gadgets, iPads, phones, and what's not, just to check, will it blend? So that's great. I can watch it for hours. Now, in our example, the question is, will it scale? We have a call from, that's too early. We have a call from a sales guy that asked the head of R&D, I have a customer that I promised them a certain load, they have a certain load, and I said that I need to check with you, will it stand this load? Will it scale? And that's the normal reaction of the head of R&D. And then he asks the developers, right? And he goes to the developers and like, guys, will it scale? And they're like, sure, of course it will scale. Absolutely. And he's like, how do you know? And they're like, well, we wrote it, so it should be fine. Everything will be fine, right? And then, of course, they sign with this customer, and the customer unleashes his load, and then this happens. For whoever doesn't know, it's the great movie 300. And basically, they all dead. It didn't scale. Yeah. So, as I mentioned, Greek tragedy, everybody dies. This is it. But we are in the Western world when we don't like the tragedies that end that bad. So we will attach a happy ending to it. And it's called the epilogue. Smokey Bear. Proactive improvement. Smokey bear, I don't know, it's like, I think it's a Californian thing. It's a bear that takes precautions so forest fires won't happen. Right? So we went from putting the fires down, preventing the fires in particular places, and here we're on the stage of proactive improvement when we will expect the fires somewhere and we will make sure that they won't happen even once. And this is a state that you as a DevOps team should strive to, and there are not very big chance that you will get to, but we should try to do our best. So what it takes? It takes some new processes. Performance and scalability testing, right? So you already have this performance engineer, and he already got the requirements. They need to be formulated in automatic tests. License and security management, right? So you need to know exactly what's going on with all your dependencies in terms of licenses and security vulnerabilities. Proactive performance and trend reviews. You need to build trends of how the performance of your application is doing. Is it increasing? Is it decreasing? Can we expect what happens next? And why? Non-functional definition of done, different from non-functional backlog. In terms of backlog, well, it's just on a backlog. This is why it's called back, because it's on the back, right? Definition of done means there is no release if the non-functional requirements are not met. It's a much stronger statement, and I see there is a gentleman that correlates with this, and that's good, right? And the good news are we have tools for almost all of those, right? So here are a couple of examples. Mission control that allows you to see those trends, and the X-ray that allows you to be in control of your licenses and security. Service virtualization that allows you to kind of mock the services that you need in the cloud so you could do your performance analysis and stuff. So the tools exist, and they actually help you solve those problems. So the problem of licenses, the problem of licenses can be solved with something called, with tool like X-ray. So here you can see there is a license violation. GPL license was found in some jar file, and we can get alert on a Docker image that includes this jar file somewhere inside, right? So we know exactly what's going on. And the problem of guessing the budget can be solved with very very advanced tools like Microsoft Excel. When you track your budget allocation, you actually know what's going on. And you can discover wonderful things. For example, most of the money don't go when you expect it to go. You thought you are working on this major new feature, but it turns out that only 30% of your money was towards the new feature. And everything else was like, keep the lights on, or this kind of stuff, right? Those trends of usage and utilization of resources, this is mission control that projects how many artifacts you will have 2 years from now, and you can build a budget, you can know what's going on, and you can understand how many storage you need, and this kind of stuff. How do we solve that? How do we know what's the quality of our product? How do we know what's the quality of our product? There is only one good metric. Customers. Customers, thank you very much, Hirsch. Customers, and how do they express their, what they think about your product? How do they express the quality?
Buy more.
Buy more, or buy less, but there is something very immediate.
They don't call you.
They don't call you, and otherwise they do call you, and they open tickets. So looking at the tickets is a very good insight of the quality of your product. So here's an example. It's a breakdown by severity on a product, and what you can see here that 65% of the tickets are either severity 1 or severity 2. What do you think about the quality of this product? It's a pretty shitty product, isn't it? Or is it? Is there another explanation here? Yes?
No one actually knows how to set severity.
Thank you very much. The support doesn't know how to set the severity or doesn't know the product. How do you know that? How do you check whether the support actually sets up the severity correctly? By looking at the resolution of the tickets. And here's another graph by resolution. And look, magic. 52% of those crazy severity tickets were fixed by telling the support how the product is intended to be used. Is the product so shitty now? No. We have something else shitty, and that's the knowledge of the support engineers, but we know how to solve it. Instead of investing more in quality of the product and without any reasonable outcome, all we need here is to train the engineers. And this conversation of your product is shitty, now you don't know anything about the product between dev and support won't happen anymore. We know the facts. So we can do something very concrete and proactive about that, right? So that's another example. Epimyth, who knows the word? Any majors in history or theater in the crowd? No. Epimyth is the morale of the story. And you learned a new word here. And the morale of new story is, first of all, scale is a scale. And there is not much you can do in order to fast forward. If you are in a fire brigade mode, no one can beat you into proactive improvement. It should happen over time with the scale, with the experience, and with the growth. And you can relate yourself to a part of those. And who is in reactive mode? Who is fighting fires non-stop as of today? Yeah, that's okay. A couple of events, that's fine. How about reactive improvement, smoke alarm installers? Make sure that this problem won't happen again. Yes, most of you are there. Who thinks that they are in the proactive improvement? No one. Okay, that makes perfect sense, right? As I told you, the majority of us are always in this stage 2, trying to get to stage 3. And 2 more things, and then you're off. First is change is made here. And there are, if you need to remember something from these talks, are those 2 things. First principle is you build it, you own it. If you remember, everything is about that. The developers are now DevOps, and they are in charge of what they do. How do you make them in charge? Pain is instructional. After a couple of wake-ups in 3 a.m., your quality of your software will be much harder. Sorry for taking your time. I somehow mismatched the hours. Q&A, we don't have time. I'm at the booth. Come to meet me here. I'm Baruch on Twitter. This is QCon London. Use the hashtag, show notes, video slides, links, feedback, and raffle. Thank you.